You know how groups and families on the periodic table are supposed to have similar properties? Well, I can't really find a relation between hydrogen and the rest of the alkali metals.
That's because hydrogen is not technically part of the alkali metals. Elements within the same family of the periodic table have similar properties because they have the same number of valence electrons, and hydrogen has one valence electron, so it's grouped with the others.
That's interesting. But don't alkali metals form hydrogen? Isn't that why hydrogen is grouped there?
Well, all alkali metals are highly reactive with water and oxygen in the air, and when it reacts with water, hydrogen gas and extreme heats are produced. But besides from that, there are other properties that separate it from the other alkali metals.
Oh yeah, like physical properties. Alkali metals are usually soft, silver-white, shiny metals that are very good conductors of heat and electricity. They also bond very easily with other substances.
Yep, that's why alkali metals are never found uncombined in nature. They are always combined with something, like how sodium is combined with chlorine to make salt, which is found in nature.
Okay, anyways, on to the next family. The alkaline earth metals have many similarities to alkali metals, so why are they different?
Well, the number of valence electrons in this family are different, and although they are similar, they are not exactly the same.
Right, and since alkaline metals have 2 valence electrons, they are not as reactive as alkali metals, but they are still so reactive that they are never found in nature uncombined.
Correct. But those metals are still useful. Like magnesium is used in many metal alloys, and calcium is important for your teeth and bones. You know what I never understood?
What?
How a big chunk in the middle of the periodic table is considered transition metals, even though many of them are not even in the same family. Like iron and gold are both considered transition metals, even though they aren't in the same column.
Well, the transition metals have similar properties to one another and to other metals, but they are different from the properties of any other family.
So basically they just put the misfits into one big family?
Yep.
But all these metals are super useful. Like we use iron in many different things and mercury in thermometers.
Yeah, because most transition elements have 2 valence electrons, these metals are pretty stable. Another fun fact is that they can share electrons when they form bonds with other atoms. So that's why so many compounds can be formed by these elements. Did you know that aluminium is the most abundant metal and the 3rd most abundant element in the Earth?
Huh, I didn't know that. All I know is that it's part of one of the families to the right of the transition metals, 5 of which contain some metalloids, meaning that certain members of these families show properties of metals as well as nonmetals.
I think I heard about that in science class the other day. They're called the boron family, the carbon family, the nitrogen family, and the oxygen family.
Huh. Family 13 is the boron family, which includes the elements whose atoms have 3 valence electrons, such as boron, aluminum, gallium, indium, and thallium.
The next family, family 14, is the carbon family, consisting of carbon, silicon, germanium, tin, and lead. These carbon atoms with 4 valence electrons can form more than 5 million different compounds.
Silicon, the second most abundant element in the Earth's crust, combines with oxygen to make sand. Silicon is also used to make glass, cement, and memory chips in a computer.
Wow, I didn't know that silicon was used in so many different ways. Another element of the carbon family, germanium, is used to make the transitioner component of radios and television. The 15th family, the nitrogen family, consists of elements nitrogen, phosphorus, arsenic, antimony, and bismuth, which all have 5 valence electrons in an atom of an element.
Nitrogen is the most abundant in the Earth's atmosphere and is used in fertilizers, medicines, explosives, and dyes. Oxygen, sulfur, selenium, tellurium, and polonium make up the oxygen family. The elements in this family have 6 valence electrons. Oxygen, the most abundant element in the Earth's crust, is very reactive and combines with almost every other element.
O3, made of 3 oxygen atoms, forms the molecule ozone. The ozone layer protects the Earth from dangerous UV radiation from the sun.
You mentioned that alkali metals are never found as lone elements in nature, but you can find salt in nature? Well, I was wondering what the other half of salt is.
Well, a salt is a compound that forms when halogen reacts with metals. Sodium chloride, commonly known as table salt, is a mixture between sodium, an alkali metal, and chlorine, a halogen.
What are the properties of a halogen?
Halogens are super reactive. In fact, they are the most active nonmetals. Because halogens have 7 valence electrons and they only need 1 more to get a complete set of 8, they are really reactive and react easily with alkali metals.
So, because halogens are super reactive, does that mean that they aren't found free in nature?
No, not naturally, but nowadays in labs you can find them in their pure forms. They are found in a variety of stages. Fluorine and chlorine are gases, bromine is a liquid, and iodine and the metalloid acetine are solids. One family that is normally unreactive, the noble gases or inert gases. Noble gases have a complete outer energy level, so they won't combine chemically with other elements unless under special conditions.
But if they don't react with anything and are found in smaller amounts in the atmosphere, how did we discover these noble gases?
Well, the first noble gas discovered was argon by Sir William Ramsay and Lord Rayleigh in 1894. Argon was found in the residue of nitrogen and oxygen.
Cool. You know what's interesting though? Argon makes up about 1% of our air, and it is the most common out of all of the noble gases.
I guess that's why all the noble gases were only discovered near the end of the 19th century. They're so scarce and unreactive.
What about the rare earth elements? They're just in 2 rows at the bottom. What group do they belong to?
Well, I guess in a way that these 2 rows could be considered their own families. The top row is called the lanthanide series, and the bottom row is called the actinide series.
Huh. So this means they have similar properties, right?
Yeah. The lanthanide series are made up of soft, malleable metals that have a higher luster and a conductivity. And the actinide series are all radioactive.
Yeah. And aren't most of the actinide series man-made elements? Like, you won't find curium just lying anywhere.
Only thorium, protactinium, uranium, neptunium, and plutonium are found in nature. The rest are made in labs by machines like californium.
It's especially cool that you can get more artificial elements from artificial elements. Californium was discovered by bombarding curium, another artificial element, with alpha particles. This was made in 1950 by Stanley Thompson, Kenneth Street Jr., Albert Gilhoso, and Glenn Seaborg.